Okay, section 3 of chapter 5 is to solve systems of linear equations by addition. So again, we've been looking at how to solve a system. Two linear equations on the same graph are being used together, compared, and we're looking to solve that. We're finding the point where the two lines intersect, or the point that works in both equations. In 5.1, we did this by graphing the two lines on the same graph and seeing visually whether they intersected, were parallel, or they were the same line. And then we just finished in 5.2 using the substitution method. Now here in 5.3 we're going to use the addition method. Some of you, if you're from my generation, were probably taught this as being called the elimination method, because you actually were attempting to add the two together to eliminate one variable. But because really both substitution and addition eliminate a variable, and then you have to go back and use back substitution to get the other variable, it just seems more relevant to talk about the process of eliminating. So that's why it became the substitution and the addition method. So we're going to be solving each system by the addition method. Again, we're looking for if there's no solution or an infinite number of solutions. No solution means you get a false statement, and that means you have parallel lines. Or if the variable falls out and you get a true statement, that means you have the same line and there's an infinite number of solutions. And of course, we'll continue to practice using set notation to express our solution sets. The steps here are already written for you. We'll talk about them. We're going to rearrange to standard form. That's your ax plus by equals c, or you may be used to seeing that in capital letters here, the ax plus by equals c. You're then going to, and so in this case both are done. We've got x, y equal to a number, and x and y equal to a number. 3x minus y equals 11. 2x plus 5y equals 13. So step 1, both equations are in standard form, so we're done with that. This next part, you get to kind of solve a little puzzle here. We're looking to eliminate one of the variables after you add the two equations together. So what we're trying to create here is equal but opposite coefficients. Okay? So you pick either the x or the y to eliminate, and then you'll multiply either one or both equations by a number that will create equal and opposite coefficients of the variable that you want to eliminate. So in this case, I'm going to pick y. It really doesn't matter which one, but your goal here is to make the coefficients in front of whichever variable you want to eliminate equal but opposite. I picked y because they're already set up to be opposite. One is negative, one is positive. I just now need to make their number in front, the coefficient match. I can do that by multiplying the top equation by 5. So already one is positive, one is negative. So that's why I'm choosing y here. I'm going to go ahead and multiply the top equation by 5, which gives me 15x minus 5y equals 11, and my bottom equation remains the same at 2x plus 5y equals 13. And what I've created here is equal but opposite coefficients. Okay, so that's step 2. What that means is that I'm now able to do step 3, which is to add these two equations together. And this is step 3. When I add them together, the equal but opposite coefficients will cause one of the variables to be eliminated. So 15x plus 2x is 17x. Negative 5y plus 5y is 0y, and 11 plus 13 is 24, leaving me with 17, I'm sorry, I've made a mistake here. I forgot when I multiplied by that 5, I need to multiply every piece by it. Made a very, very common mistake here. I should get 55 instead of 11. So 55 plus 13 is going to give me 68. Whew. Wish I wouldn't have made that mistake, but at least I caught it before I got too far. So watch for that. That's a very common mistake. So stay focused. From there, I will rewrite that as just 17x equals 68. The y's were eliminated. That was what we were trying to do, so it shouldn't come as too much of a shock to us. And then we divide both sides by 17, and we get x is equal to 4. From there, we can use back substitution to plug that in. So this is 4 right here. We'll go ahead and use the bottom equation. Again, it really doesn't matter which one, but 2 times x plus 5y equals 13. Go ahead and take that 4 value, put it in. That gives us 8 plus 5y equals 13. Subtract both sides by 8. 5y equals 5. Divide by 5. Y equals 1. Check that in both equations. A y value of 1, x of 4, 3 times 4 is 12, minus 1 is 11, that does check. Second equation, check it, 2 times 4 is 8, plus 5 times 1 is 5, 8 plus 5 is 13. So they both check. And that was our step 5. So we are now free to write this in set notation. It's the 0.41.